Assalamu alaikum dear students. I hope that everyone is doing well. We have to continue with same unit, basic statistics. And today we will be covering the topics measures of central tendency and graphical location of median, quartiles and mode. In the previous class, we learned about the measures of central tendency, that the measures or techniques that are used to determine a single value is known as measures of central tendency, whereas central tendency is the specific value around which majority of the observations tend to concentrate. Then we learned different measures of central tendency in the previous classes: the arithmetic mean, median, mode, geometric mean, and harmonic mean. Today we will learn another measure of central tendency known as quartiles. Besides this, we will learn the computation of moving averages and graphical location of median, mode, and quartiles. So let's begin with the definition of quartiles. A quartile divides a data set into 4 equal parts so that each part represents 1/4 of the data set. For instance, if this is the data set, so quartiles divide this data set into 4 equal parts so that each part represents 1/4 of the data set. Here we have a lower quartile denoted by Q1. This is the quartile 2, known as middle quartile or median, because Q2 exactly falls in the middle of the data. Therefore, Q2 is also known as median. Q3 is known as upper quartile. Here we have some more explanation of quartiles, that Q1 covers the 25% of the data. Q2 covers the 50% of the data because it exactly falls in the middle, and Q3 covers the 75% of the data. So why we calculate the quartiles? When we are interested to represent the 25% of the data, the average of 25% of the data, so we can calculate quartile 1. If you want to know about the middle of the data, so we will calculate Q2. If we are interested to find a representative of the 75% of the data, so we calculate Q3. For instance, we have the data set, and here this data set is divided into 4 equal parts by the help of, or by these 3 quartiles. So you can see that 4 is the representative of Q1, the 50% of the data. This is exactly in the middle, known as median or quartile 2, whereas the 7 is the upper quartile Q3, because it is the representative of 75% of the data. Here we have moving averages. Moving averages are defined as the successive averages which are computed for a sequence of days, months, years at a time. If you want to find 3 days moving average, for instance, we find the average of first 3 days, then dropping the first day and add the succeeding day to this group. We have to place the average of each 3 days against the mid of the 3 days. This process continues until all the days beginning from first to the last are exhausted. We can better understand the moving averages with the help of the question given in exercise 6.2. This is question number 12, where we are supposed to calculate simple moving average of 3 years from the given data. We can calculate moving averages for the years, for the months, for the days up to the requirement. Moreover, we can calculate moving averages for 3 years, for 5 years, for 2 years, for 10 years, depending on the need. So let's assume that this data is about the output or production of a certain firm, where the years are given from 2001 till 2010, and the value or the output or the production is given here against each class. So let me tell you here that why we calculate moving averages, what is the need of calculating moving averages. So moving averages are calculated if a firm, a certain firm or a company want to compare the years. That in first 3 years or first 5 years the average production is good or was good, or in the next 3 years or in the next 5 years, and in the same way in the next 5 years. So this is basically done for the sake of comparison. So let's learn it better here, that how we can compare it. For instance, here we have to find the average of 3 years. So we can take the first 3 years, 2001, 2002 and 2003, where the production is 102, production of 2002 is 108 and the production of 2003 is 130. So we have to calculate the average for first 3 years. Average is calculated by adding all the values and then dividing by the number of observations. Since we are taking 3 years, so we have to take 3 values from here. We have to find the total for calculating average. The total of 102 plus 108 plus 130 is 340, this one. Now, in order to find the average, we have to divide it by 3 because we have 3 values. So the average will be 113. Here you can write 3 years total. And here we can write 3 years moving average. Okay. Let me tell you one important thing here, that the average or the total should be written in the middle of these 3 years, as it is discussed that average of each 3 days against the mid of 3 days. So 2001, 2002, 2003, which one is the mid? The middle is 2002, so therefore the average or the total should be written against 2002. As average is the central value, so therefore it is decided to be written in front of the or against the middle one. We have to skip here this 340 should not be written against 2001. Now what we have to do, we have to drop the first year. Now we have to find the average of the next 3 years, 2002, 2003 and 2004, for the sake of comparison with the first 3 years. So the output in these respective or in these 3 years are 108, 103, 130 and 140. So the total of this should be written against 2003 because this is the mid year here, and it should be divided by 3, so the average will be 126. Now we can easily compare the production of first 3 years and the next 3 years. The production of first 3 years is 113, whereas the next 3 years is 126. So now we can say that in the next 3 years the production is better than the first 3 years. Similarly, now we can drop 2002 and we can now pick up 2003, 2004 and 2005. The total of this will be written against 2004, which is 428, and this is the average, and we have to continue the same process till the end. Here the average of these 3 years is the total is 660 and the average is 220. So this is the moving averages. Here we have the last question of exercise 6.2, where we are supposed to determine graphically for the following data. Then we have to check our answer by using formulas. What we have to determine? We have to determine median, quartiles using cumulative frequency polygon. Since we are dealing with the basic statistics, so therefore the graph is given in the question that for median and quartiles we can use the graph cumulative frequency polygon, whereas in order to determine the mode we can use histogram. So here the data is given. We can find the median, quartiles and mode with the help of formulas as well, as we have discussed in the previous class. Moreover, we can find the median, quartiles and mode with the help of graph. Sometimes if we found the formula difficult, or if we find the formulas difficult to be applied, or if you are not interested to use formulas, so we can we can go to the alternate method, that is determining the central values with the help of graphs. So first we will determine these measures of central tendency with the graph, and then we are going to check our answer or verify our answer by using formulas. So here let's see that for cumulative frequency polygon, what we have to make an additional column is required or not. Of course, since we are going to go with cumulative frequency polygon, so we must have the column of cumulative frequency. So here we have the cumulative frequency column. What we do in cumulative frequency, we add the frequency of each successive class Here it is 2, 2 plus 5, 7, 7 plus 9, 16, 16 plus 6, 22, 22 plus 4, 26, 26 plus 1, 27. This is cumulative frequency. Now in order to determine the median, we will take a start from median. What we have to do, first of all, we must determine median class. We cannot determine the median, or we cannot find the value of median until and unless the median class is determined. So let's find the median class. Median class can be found out by dividing the total observation by half, because median falls in the middle, so therefore the data should be divided by 2. The number of observation n is 27. When we will divide by 2, we will get the half, which is 13.5 or 13.5. Now we are supposed to find the 13.5th observation lies in which class, and this can be done with the help of cumulative frequency. So therefore we have made the column of cumulative frequency. We can see that in first class we have 2 values, in the second class we have 7 values, and in third class we have 16 values, and we are supposed to see that 13.5 lies where. So of course 13.5 lies in 30 to 40 class, because here the cumulative frequency is 16. Here how many observations are till this class? The last limit is 16, so it means it will be in the third class in 30 to 40. You can highlight this and you can write that this is the median class. Now when the median class is found, so we can determine it graphically. Here, before determining it, we have to make the cumulative frequency polygon first. So the class boundaries means upper class boundaries. I'm talking about the upper class boundaries. We have to take the upper class boundaries on the x-axis and the cumulative frequency on the y-axis. So let's see that what are the upper class boundaries. We can take a start from 10. We cannot neglect the 10 because 10 is the start. So 10, 20, 30, 40, 50, 60, 70. Because 20 is again repeated here, so just upper class boundaries are taken. 10, 20, 30, 40, 50, 60, 70. This should be with a proper scale. It should be taken on y-axis, whereas cumulative frequency is taken on x-axis. On y-axis, and class boundaries on x-axis. So here with the 3 gap, it is made the cumulative frequency, and the last limit is 27 here. Okay, now we have to plot this. You can see that against upper class boundary 2 has how many cumulative frequency, or what is the cumulative frequency? 2, 10. It's like less than cumulative frequency. So less than 10, we don't have any value, so it will be 0. Less than 20, the cumulative frequency is 2. Less than 30, it is 7. Less than 40, it is 16. Less than 50, it is 22. Less than 60, it is 26. And less than 70, it is 27. So here you can see that less than 10, 0. So it is touched with the 0. Less than 22, we have 2. So here it is 2. Less than 30, we have 7, so it will be 7. Less than 40, it is, I think, 16. It's 16, and similarly we have to mark the cumulative frequency, then 22, and then the last one is 27. Less than 70 it is. So here this is less than 70. Now when the cumulative frequency polygon will be met, we have to determine the median. So we can see what is the cumulative frequency of median. It is 16. So we have to look at, or we have to find the 16. From here, what we have to do, we have on the graph of y-axis, we have to draw a horizontal line segment so that it touches the graph of we can say frequency polygon, where it touches. So from there we have to draw a vertical line segment from this point touching the x-axis. Now where it will touch the x-axis, we have to read that value, which is near about 30. We can say that 50. It is 37. If you will use graph paper, you can count this, that one block is divided into 10 equal parts. So 1, 2, 3, 4, 5, 6, 7. You will get 37. This is the median. We have determined it with the help of graph. Now we are going to verify it with the help of formula. So here we have the formula. The formula for median is L plus HF divided by N divided by 2 minus C. L is the lower class boundary, which is 30 of the median class. H is the class height or class size, which we can find it by subtracting upper class limits or by finding the difference of the lower class limit. 30 minus 20, 10. 20 minus 10 will get 10. So this is the class size. H is the value of H is 10. Okay, N is 27, F is the frequency of the median class, which is 9, and C is the cumulative frequency preceding to the median class. So C is the 7 preceding to the median class. We can put this in the formula: 30, 10 divided by 9, 27 divided by 2 minus 7. You can use the calculator for calculation. Here the LCM is taken and you will get 13 divided by 2. So that we will get the median 37.22. Median, this is the symbol for median, and here we can write this symbol. This is for median. Now let's compare 37.22 with the answer found with the help of graph. With the help of graph, we have also the value as 37. There is a little difference which doesn't matter. So here we have verified the result. Now we are supposed to find the quartiles. Okay, for the quartiles, first of all, we have to determine that Q1 lies in which class. So here we can see that for Q1 we have to divide n by 4. Why n by 4? Because quartiles divide the data into 4 parts. So therefore the total data should be divided by 4 parts. The denominator shows that in how many parts the data is divided into 4 parts, and how many parts we have to select. How many parts we have to select? 1 part, because quartile 1 covers the 1 part of the data, the 25%. So here numerator shows how many parts are obtained. So from 27 we can obtain 1 part. So 27 divided by 4, we will get 6.75, the 1 part of the observation. Now we have to see that 6.75 lies in which class. So we can find it with the help of cumulative frequency. Here we can see that till this class we have 7th values or 7th observations. So of course 6.75 lies in which class? In 20 to 30, so this will be Q1. Now the frequency of this class is 5. The frequency preceding to this class is 2. The height is, the class size is of course 10, and the lower class boundary is 20. So we can put this in the formula for the sake of verification here. Here you can see 10 plus 20 plus 10 upon 5, 27 divided by 4, and 2 is the cumulative frequency preceding to the median class. We will get the answer 29.5. Now let's look at this on the graph. We can see that the cumulative frequency of 20 to 30 is 7. So from 7 we are going to draw a horizontal line which will touch the graph of frequency polygon, and from that point we are going to draw a vertical line which will touch the x-axis. So from there you will read the value which is near about 30, which that is 29. So Q1 is 29. And with the help of formula we have also found 29.5, which is almost similar. Now we have to calculate Q3. So we can say that first of all we have to find the Q3. Here we can see that n is divided into 4 parts in quartiles, and in Q3 how many parts we take? 1 part, 2 part, and 3 parts. So here we are going to write 3 and divided by 4. In median, when n is divided by 4, so how many parts we take? We take 2 of the parts. So when it's further divided to 1 is 2, 2 2s are 4, so we can get n by 2. N by 2 is for median, or you can write in this form as well. 3n divided by 4 is for calculating the quartile 3 or the upper quartile, and n divided by 4 we will just take one of the part, it will be quartile 1. So therefore here the formula is, the rest formula is same, just we have to change the observation. Okay, that which part of the data we are supposed to select. and that for how much part of the data we have to find the representative. So 3n divided by fourth of the observation, the Q3 contain 3n divided by fourth part of the observation, so that we will get 20.25th observation. Now we are going to see that 20.25th of the observation lies in which class. So we can check it through the cumulative frequency here. Till this class we have 16, and till the next class how many observations we have? 22. So 20th observation of course lies in this class, which is 4250. So this will be our Q3. You can highlight this. The frequency of this is 6. The frequency preceding to this is 16. The height is class height is 10, and the lower class boundary is 4. So we can put this same in the formula here. Okay, here we have put in the formula. After calculation you will get 47.08. calculation you can do it yourself. Okay, now when we will look at this on the graph, so against the 40 to 50 a class, we have the cumulative frequency 22. So from 22 we have to draw a horizontal line, then we are going to drop a vertical line here, then this will be the cumulative. We can say that it will be the Q3, which is 47. Okay, here the same graph, this is 47. It is near about 50. With the help of graph paper you can easily count that each block 1, then 2, then 3, then 4, then 5, then 6, then 7, equally it will be divided. So by the help of the formula we have the same answer, a little bit difference of decimal, which doesn't matter. So it is verified here. Now we have to proceed towards the second part of question number 13, which is that we have to calculate a mode using histogram. We have to verify the answer as well by using formula. So first of all, let's see that for histogram what we have, do we need an additional column? No, because histogram is the graph of adjacent rectangle where the frequency is plotted against the class boundaries. Here already we have the class boundaries, so no need to make it. 10, 20, 30, 20, 30, 30, 40, 50, 60, 60, 70. This is the class boundaries. These are the class boundaries, and here the frequency is plotted against the y-axis. Okay, now we are going to make the adjacent rectangles. Okay, here we can see that 10, 20. Against 10 and 20 we have the frequency 2. So this is the height of the rectangle depends on the frequency. So 10, 20 with 2, 20 and 30, what is the frequency? 5. So is 5. Then we have 30 to 40, the frequency is 9. So here it is 9, and similarly the next one is 6 and 1. So you can see that this one will be 6. It will be a little bit here, I think. Okay, it's 9. After 9 we have 6, then 1. If this is 9, so this will be 6, and this one is additional here. I think just this one, 60 to 70 will be equal 1. Okay, this is okay, 50 and 60. Here one is missing, I think. Yeah, one column is missing. It's 50 to 60. The frequency is, let me check it from your book. The frequency of 50 to 60 is, it's 4. So this is not additional. This is the frequency of this is 4. So this is correct. Okay. Now we have to see that which one of these will be the mode or the model class. So of course the rectangle having the highest peak indicates the model class. Why? Because according to the definition of mode, the frequent observation is known as mode. So which class has the highest frequency? 30 to 40. So this is the model class, or the rectangle with highest peak is the model class. So this is the model class. Now in order to find the specific value, here we have just determined the model class. Now we have to find that specific value, the mode, a single value. As in this rectangle there will be range of values. So what is the steps for that? We have to draw a line segment from the top left corner of the rectangle. Let me have pointer. This is top left corner of the rectangle. We have to draw a line segment, and we are going to touch that line segment to the top left corner of the succeeding rectangle. This is the succeeding rectangle, so this green line you can show, you can see it has means from the top left corner start is taken, and it has touched the top left corner of the succeeding rectangle. So next step is to draw another line segment from the right corner, from the top right corner of the rectangle, and it should meet the top right corner of the preceding rectangle. You can see the blue line. So here, after it is done, we have to drop a perpendicular from the top of the rectangle. This is the top of rectangle. We have to drop a perpendicular, means a straight line to the rectangle, from the top of the rectangle to the x-axis, passing through the point of intersection of the line segments. We have to drop a perpendicular from the top of the rectangle, but the condition is that it must pass through the point of intersection of first two line segments. So you can see that this this yellow line is passing through the point of intersection, and it should meet the x-axis. The only point where it will touch the x-axis, this perpendicular line, so you have to observe that value is the mode. So if you will use the graph paper, then you can count the 30, 31, 32, 33. It will be, mode will be 33. If it will be a little bit difference like 33.3 or 33.9, it doesn't matter. But you must have the correct scale for the histogram. It should be all the rectangles should be of equal width. The size depends on the, or the height depends on the frequencies. So here is the mode. Now in order to verify that whether the graph has given us the correct answer, we can use the formula. Here's the formula for calculating mode for the group data L plus Fm minus F1 to Fm minus F1 minus F2 multiplied by H. Fm is the frequency of the model class, F1 is the frequency of the model class preceding to it, and F2 is the frequency of the class succeeding to the model class. So here the model class is 30 to 40. We can see that the frequency of the model class is 9. Preceding to it, it is 5, and succeeding to it, it is 6. So we can put this in the formula. 9 minus 5, 2 multiplied by 9 minus 5 minus 6. After calculation, 30 written as it is 4, 18 minus 11, 9 2s are 18, minus plus 5 minus 6, it will be minus 5 minus 6 will result in minus 11. After calculation, we will get 5.7, and 35.7 is the mode according to the formula. There is a little difference, but it's not much difference. So this is basically the mode with the help of formula and with the help of graphs. Here is your homework for today. You have to do exercise 6.2, question number 12 and question number 13 in neat notebook, which is already explained here. Stay blessed. This is all for today. Have a nice day, and thank you.